Hey SJ!
Hi Annabelle! Like my airplane?
Yeah!
Let's see it fly! Why won't my airplane fly?
SJ, to make your airplane fly, we will have to adjust your throwing to the wind. So to do this, we will use vectors. And to use vectors, we need to know that the plane is going 225 feet per hour at a bearing of 205 degrees. And then we also need to know that the wind is blowing at 60 feet per hour at a bearing of 100 degrees. This tells us that the wind alters the plane's course. Here is a visual aid of the two graphs. At the top, we have the plane's graph, and at the bottom, we have the winds. Here is the plane's flight of travel at 225 feet per hour, the bearing of 205 degrees. We will be using a north, east, south, and west graph instead of an X and Y. At the bottom, we have the wind going at 60 feet per hour with a bearing of 100 degrees. Here I have drawn in the third line to make a triangle. The third line is where the plane should end up once you factor in the wind. But we don't know how many feet per hour this is or what bearing it has, so using vectors we are going to figure this out. So we know the bearing of the plane is 205 degrees, and that the degree of a circle is 360 degrees. So if we subtract 205 degrees from 360 degrees, we get 155 degrees. And because the two graphs are parallel and the plane's flight is intersecting both of the parallel lines, we can use alternate interior angles to move the 155 degrees to the second graph. Now, we know the bearing of the wind is 100 degrees. And we know that this is a straight line, so we know that it is 180 degrees. Now, if we subtract 100 from 180, we get 80 degrees. So, if we subtract 80 from 155, we will get the middle angle, which is the interior angle of the triangle. So, if we subtract 80 from 155, we get 75 degrees, meaning that the inside angle of the triangle is 75 degrees. So now that we know that one interior angle is 75 degrees, we can use the law of cosines to find the actual course of the plane. So, using the law of cosines, we know that c squared equals 225 squared plus 60 squared minus 2. And then we know that 225 times 60 times cosine of 75 degrees means that c equals 217 feet per hour. So, now we know that the actual course of the plane is 217 feet per hour, but we don't know the bearing yet. So to find the bearing, we first need to find the tip of the triangle. And to find the very top angle of the triangle, we are going to use the law of sines. So, using the law of sines, we know that sine 75 is equal to 217. And we know that sine theta, which would be the angle at the top of the triangle, is equal to 60. So, using the law of sines, we find that the interior angle of the triangle is 15.5 degrees. But this is not the actual bearing of the plane. So, to find that, we must subtract it from the original bearing of the plane, which was 205, and then we get 189.5 degrees. So, using vectors, we found that the new course of the plane was 217 feet per hour with a bearing of 189.5 degrees.
It was just the wind. It was just the wind. Let's see it fly.